Hey everyone, my name is Rifki Afan with student ID 2410912053. In this video, I am going to explain to you about dial indicator. So let's jump right in. Uh, Today, I'm going to be helped by this video animation while I dub the video. So, what is dial indicator really is? Dial indicator, often referred as dial gauge, is a precision measuring instrument widely used in mechanical engineering and metrology. It is designed to measure minute linear distances, surface irregularities, or mechanical runout, and it visually amplifies this tiny measurement on a readable dial face. In this video, we are going to talk about first is the working principle of dial indicator. Second is the construction of dial indicator. The third is how it working principle of dial indicator, and fourth is the applications. And fifth is the advantages and disadvantages of dial indicator. First, the working principle of dial indicator. So the fundamental working principle of dial indicator is the conversion of a very small linear straight line movement into highly magnified rotary circular movement. Specifically, every slight upward pressure in the spindle plunger at the contact point is multiplied through a system of gears and levers, and it is indicated on the face of and it is indicated by the face of dial by the pointer. And to understand this, we look at this four main components. There are body, graduated scale, contact point, and pointer. So the body is acts as the protective housing for the delicate internal mechanism, and the contact point is the part that is physically touches the working piece, the workpiece being measured. As the workpiece surface changes, the contact point moves up or down, and there is the pointer, which is acts like the hand of a clock, sweeping across the face of the instrument to indicate the measurement. There are also a graduated scale. This is the printed dial face behind the pointer, featuring precise markings, usually in a hundredth of a millimeters or a thousandth of an inch, so the operator can read the exact value. Okay, the second is we are going to talk about the construction of uh, dial indicator. To understand its functions, we need to break down its construction into there's a external and internal components. The external components is from the front view. We can see there is a circular dial body, which is the main outer casing holding the dial. There is pointer, the main hand indicating the current measurement. There is a graduated scale, that is the numbered markings on the dial face, and there is a revolution counter. A revolution counter is a smaller secondary dial inside the main face that tracks how many full uh, 360 degrees rotation or one full revolution has the main pointer has made. There also the bezel. There is also the bezel. The bezel is the rotating outer ring surrounding the dial face. It allows the operator to rotate to the zero mark, that is for to align with the pointer before starting the measurement. There is also the bezel clamp. This is a small screw or knob used to lock in bezel in place once it's zeroed. There's also this dust cap. It is located at the top. It protects the upper part of the internal mechanism from the dust and debris. And on the bottom part of it, there's also a stem that is the smooth cylindrical sleeve extending from the bottom of the body, which guides the plunger. And the plunger is consists of the spindle and the contact point. So the spindle is the main rod sliding through the stem, and the contact point is the replaceable tip at the very bottom. From the side view, we can see that uh, there is consist of crystal. There is just the glass or a plastic cover on the front of the pointer and the dial. There is also back. There is just the rear cover of the body, and there is also a mounting lock. Mounting lock is a flat bracket on the back of the plate used to secure the indicator to a magnetic stand or a fixture. And we see in the internal parts of the dial indicator. It is consist of first there is the rack. Rack is a straight strip of gear teeth cut directly into the side of the plunger. There is also a rack guide. It is a component that prevents the rack from rotating, ensuring it's only moved straight up or straight down. There is also the gear train, a series of interlocking gears and pinions that multiply the movement. There is also a coil spring here. It is a spring that pushes the plunger downward and maintaining constant contact pressure against the workpiece. And there is also hairspring. Hairspring is a fine coil spring attached to the final gear to maintain constant tension and eliminate the play or backlash between the gear teeth. Okay, then we go to the working of dial indicator or how it works. Okay, how does the dial indicator actually achieve such high magnification? It all comes down to the gear train and principle of gear ratios. Because before we really talk about how all of the parts work together, let's first we discuss about how this magnification is achieved. So that considers there are two gear meshing each other. A small gear is the gear A, or you can call it pinion, and the larger gear is gear B. So gear A has significantly fewer teeth than the gear B. So if you rotate this small pinion exactly one full revolution, the larger gear B will only rotate a fraction of a revolution. Conversely, if you rotate the larger gear B exactly one full revolution, it forces the small pinion gear A to spin multiple of revolutions. This mechanical multiplier effect is exactly how magnification is achieved in dial gauge. A tiny slow movement at the start of the gear train translates into a massive, fast sweep of the pointer at the end. Now, how all of the parts work together. Let's trace the movement from the workpiece to the pointer. Okay, first, when the contact point hits a high spot on a surface, the plunger is pushed upward. So the rack kept in perfect alignment by the rack pin and the rack guide moves up along with the plunger. This upward motion compresses the coil spring. Then the straight teeth of the rack mesh with a small starting pinion as the rack moves up, it forces the pinion to turn. This rotational motion is transferred through the gear train. For example, the starting pinion drives this gear B. Uh, the starting pinion drives this gear B, and gear B meshes with pinion C, which is the small gear pinion C, which is also turn the drives gear D. And finally, this gear D meshes with the pinion E, and this pinion E is mounted on the exact same central shaft as the main pointer indicator. Because of the sequential gear ratios, a microscopic linear lift of the plunger result in the pinion E and the pointer sweeping significantly across the graduated scale. Throughout this entire process, the hairspring is applies applies a constant rotational tension against the gear train. This ensures the gear teeth are always tight against one another, preventing backlash and slack so that the measurement is completely accurate whether the plunger is moving up or moving down. Okay, and the result of the measurement will be displayed on this on the pointer. But also you need to check the graduated scale if it's already rotate 360 degrees or how many resolutional has it made. The next thing is we are going to discuss about the applications of dial indicator. So first is dial indicator can compare two heights of distance between a narrow limits. Second is to determine the errors in the geometrical forms such as ovality, roundness, and taper. Third one is dial indicator is for taking accurate measurements of deformation such as intention and compression. Fourth is to determine positional error of surfaces such as parallelism, squareness, and alignment. Fifth is to check the alignment of less center by using a suitable accurate bar between the centers. Sixth is to check the trueness of milling machine arbors and to check the parallelism of sharper arm with table surface or vise. Okay, and next we are going to talk about the advantages of dial indicator. First, dial indicator is the most flawless tool in taking linear measurements. Second, moreover, dial indicators are also be used to measure several deviations by aligning with some other attachments. Third is due to the small tolerances, the size of the tool is very compact and thus it can be used seamlessly in mass production. Fourth is out of roundness. The amount of taper can also measured efficiently by dial indicators. Fifth, the tool is very efficient to ensure the quality of a workpiece. Sixth, dial indicator is also used in dimension control. Okay, next one is we're going to talk about the disadvantages of dial indicator. The disadvantage is One, the precision of dial indicator often lost due to the vibration of machinery. Two is another crucial disadvantage of dial indicator is the parallax effect. Well, you can Google that yourself. And what is that? Also, and three is space constraints can lead to installing the tool at an angle due to which precision of measuring device is lost. So the space constraints is can lead to measuring less precision of measuring device measuring. Okay, so that's all from me. My name is Rifki Afan with student ID 2410912 053. Thank you for your attention. Thank you for the time. Assalamualaikum warahmatullahi wabarakatuh.